Hi all. Already we had discussed up to digital and analog transmission in last video. And in this video we can discuss about transmission impairments. What do you mean by transmission impairments? It is actually some loss in signal. Okay. Whenever the signal is traveled through a medium, the signal strength at the beginning of the medium is not same as that of the signal at the end of the medium. So there are three causes of impairments. One is attenuation, second one distortion, and the third one noise. Okay, so transmission impairments due to some loss in strength or loss in shape, etc. Okay, so there are three causes of impairment: attenuation, distortion, and noise. So we can study the first cause of a transmission impairment, that is attenuation. So it's actually loss of energy in the signal. That is, signal strength at the center is not equal to the signal strength at the receiver or at the destination. So we have to measure the signal strength at different points, that is at center or at the receiver. Also we can measure the signal strength of two signals. Okay, so for that there is a unit of measurement of attenuation, that is decibel. So how the decibel can be expressed: dB is equal to 10 log base 10 P2 by P1. Then what is P2? Power of the signal at the point 2. And what is P1? It is the power of the signal at the point P1. At the point 1. Okay. Also, this equation can be, or this decibel can be expressed in terms of voltage. So dB is equal to 20 log base 10 V2 by V1. V2 is the voltage level at the point 2 and V1 is the voltage level at the point 1. So attenuation means it is a loss of energy. I think you understood. Okay. First transmission impairment is attenuation, loss of energy. Then why this loss of energy happen in a medium? Because there are some resistance in the medium. Due to that resistance, loss of energy is happened. So that property is known as attenuation, and this can be measured in decibel. So dB can be expressed as 10 log base 10 P2 by P1, or it can be expressed as 20 log base 10 V2 by V1. And the next transmission impairment cause is distortion. What is actually distortion? It is some loss of shape, or signal changes its form or shape. Actually, the composite signal is made up of different signals, and all the signals have different frequency, or that means a lot of or a range of frequencies are there in the composite signal. So in a composite signal, each signal component has its own propagation speed. So there should be some delay to reaching at the final destination. So there is a difference in phase in the receiver end. So distortion means actually there are some shape change at the receiver side in the composite signal. That is actually distortion. So second transmission impairment is distortion. And the third transmission impairment, noise. Actually the noise is an unwanted signal, right? So there are four types of noise we can discuss here. One is thermal noise, induced noise, crosstalk, and impulse noise. Then what do you mean by thermal noise? It's an unwanted signal, and it is due to the random motion of electrons, okay, which creates some extra signals at the receiver side that was not originally sent by the transmitter. So that is actually thermal noise. Okay. The noise, there are of different types of noises are there. In this chapter we are discussing four types of noises. One is thermal noise, second one induced noise, crosstalk, and impulse noise. Okay, actually what is noise? Noise is an unwanted signal. Okay, and first one, thermal noise. Thermal noise is a noise which has happened when the random motion of electrons in the wire is there. So which creates some extra signals at the receiver side which are not actually sent by the transmitter. Okay, and the second noise is induced noise. Sources are motors or some electrical appliances. Okay, here this device is acting as an antenna, sending antenna, but the transmission medium act as a receiving antenna. That is induced noise. Clear? And the third one, crosstalk. It is actually the effect of one wire on the other. That is, one wire acts as a sending antenna and the other acts as a receiving antenna. Due to some resistance in the wire, there will be a crosstalk, or some unwanted signals are created. That unwanted signals are known as crosstalk. Okay, and the fourth one is impulse noise. It is a spike that comes from the power lines or lightning and so on. Okay, so there are four types of noises are there. One is thermal noise, induced noise, crosstalk and impulse noise. Okay, so the transmission impairments are of three types, or the causes of transmission impairments are of three. One is attenuation, second one distortion, and the third one noise. Next, what do you mean by signal to noise ratio? Sorry, ratio, not ratio, it's ratio, signal to noise ratio, SNR. So SNR is equal to average signal power divide average noise power. That means it is the ratio of wanted signal with unwanted signal. Okay, if there is a high SNR means the signal contains less amount of noise. If we have a low SNR means signal is corrupted by noise, or signal contains a large number of unwanted signals. Okay, and how it is expressed, or the unit of signal to noise ratio is decibel units. So SNR is equal to 10 log base 10 SNR. SNR dB is equal to 10 log 10 SNR. Okay, that means SNR dB equal to 10 log 10 SNR. Okay, SNR is average signal power by average noise power. Then how it is expressed in decibel? So left hand side of the equation is SNR dB, that is in decibel units. That is equal to 10 log base 10 SNR. Clear? So it is signal to noise ratio, not ration. It's a mistake. So clear it. Signal to noise ratio. Okay. SNR is average signal power by average noise power. So it's the ratio between wanted signal to the unwanted signal. So how it is expressed in decibel? That is SNR dB. Okay, equal to 10 log base 10 SNR. And the next portion, how we can analyze the network performance. So features that affect the network performance are, first one is a bandwidth. There are 5 factors which affect the network performance. First one is a bandwidth, second one throughput, third one latency, fourth one bandwidth delay product, then fifth one is jitter. Clear? So there are 5 factors which affects the performance of a network, and the first one, bandwidth. So what is the bandwidth? A composite signal contains a range of frequency, right? Bandwidth is the difference between the highest frequency to the lowest frequency. So we can express in hertz. Also it can be expressed in bits per second. Okay, so first feature that affect the network performance is bandwidth. Clear? Bandwidth can be represented in hertz as well as bits per second. and bandwidth is the difference between highest frequency signal to the lowest frequency signal in a composite signal. Clear? And what is second factor that affects the network performance? Throughput. It is the measure of how fast we can actually send the data through a network. Okay, what is the speed that we actually send the data over a network is the throughput. It is the actual measurement. Clear? Then third one, latency. Latency means delay. Okay, it defines how long it takes for an entire message to completely arrive at the destination from the time the first bit is sent out from the source. What is the delay of sending a message from sender to receiver? That is actually latency. So latency is actually, it is equal to propagation time plus transmission time plus queuing time plus processing delay. So it's a combination of propagation time, transmission time, queuing time and processing delay. So the latency has four components. Which are they? Propagation speed or propagation time, transmission time, queuing time and processing delay. We can see each one of this. Propagation time is the time required for a bit to travel from source to destination. So what is propagation time? It is the time for taking one bit to travel from source to destination. So propagation time is equal to propagation speed by distance. Distance by propagation speed. Propagation time is equal to distance by propagation speed. And what is transmission time? It depends upon the size of the message and bandwidth of the channel. So the transmission time is equal to message size by bandwidth. Okay. Third factor that affects the network performance is latency. Latency is actually delay. It has four components. One is propagation time, second one transmission time, third one queuing time and fourth one processing delay. So what is propagation time? Propagation time is the time required for a bit to travel from source to destination. So it is equal to distance by propagation speed. Okay. And the transmission time, which depends upon the message size as well as bandwidth. So the transmission time is equal to message size by bandwidth. Okay. And next component of latency is queuing time. Actually, what is the use of a queue in a data structure? Queue which is used to store the data or store the information, right? So queuing time is the time needed for each intermediate or end devices to hold the message before it can be processed. Before a message is processed, it will be in a queue. So what is the time that is required for the message to be present in a queue? That is the queuing time. Okay, actually it depends upon the load on the network. And the last one is processing delay. How much time it takes to process a message, that is the processing delay. Clear? So the third factor. First factor which affects the network performance is bandwidth. Second one is a throughput and the third one is a latency. Fourth one, it's a bandwidth delay product. It is the product of bandwidth and delay. We have a bandwidth and we have a latency or delay, and the product will give a bandwidth delay product. Clear? And it is the number of bits that can fill the link. And the fifth one, it's a jitter. Jitter we had already discussed. It's a variation in reaching the message. It is related to delay. If different packets of data encounter different delays and the application using the data at the receiver side is time sensitive, then jitter occurs. If we have a number of different packets for a message and each packet have a different delay, so it will affect, definitely it will affect the message at the destinations. It will cause some delays. So this is actually variation in the arrival of the packet. So it's a jitter. So jitter occurs. Clear? So these are the 5 factors which affect the network performance. One is bandwidth, throughput, latency, bandwidth, delay, product, and jitter. Clear? Next, how we can analyze or how we can calculate the data rate. What is actually data rate? The rate at which the data transmits through a medium, or how fast we can send the data over a medium. Okay, so it actually depends upon 3 factors: bandwidth available, level of signal we use, and the quality of the channel. Okay, so we are using 2 theoretical formulas for calculating the data rate over a network. One is for noiseless channel, a channel without a noise, and one is for noisy channel. Okay, for noiseless channel we are using a formula, that is Nyquist bitrate equation. Nyquist bitrate equation. So what is it? Bitrate or data rate is equal to 2 into bandwidth into log base 2 L. Bandwidth means bandwidth of the channel. L is the number of signal levels. Capital L is the number of signal levels. So bitrate can be expressed in bits per second. This is actually for noiseless channel. What is a noiseless channel? A channel without unwanted signals. Okay. And the second equation is Shannon capacity for noisy channel. So how it is expressed? Capacity is equal to bandwidth into log base 2 1 plus SNR. Then what is SNR? SNR is a signal to noise ratio. And what is signal to noise ratio? Signal to noise ratio is the ratio between wanted signal with unwanted signal. Clear? So there are 2 equations for calculating the data rate over a network. One is for noiseless channel and the other is for noisy channel. Noiseless channel, it is Nyquist bit rate, and second one, noisy channel, it's Shannon capacity. Okay, so these are all about the first module. Thank you.